Hello everyone, welcome to this session, that is a gas welding. In the previous session I have discussed about the welding definition and the arc welding. Now I am going to continue another type of the welding, that is a gas welding. In the gas welding we will discuss that is what is meant by gas welding. It is a fusion welding. Fusion welding means here whatever the metal is there, pieces are there, those are to be joined, that is to be melted to its molten state, that is called as fusion welding. And here the filler material may be added in order to have that is proper joint. And in this one, fusion welding, as we know that one, the metal is to be melted to its molten state, and for that the heat supply is required. That heat, whatever the supply is there, that is by the combustion of the gas, and that combustion of the gas, from that whatever the flame is there, that is used for heating of the base metal as well as that filler rod. Here in this fusion welding, in which a strong gas flame is used to raise the temperature of the workpiece to melt them. As in the arc welding, a filler metal is used to fill the joint. And there are two types of gas welding. The what type of gas we are going to use for the combustion, based on that there are two types of gas weldings. The first one is the oxygen and acetylene welding, that is called as the oxy-acetylene welding. And acetylene is a combustible gas is used in this one. And in the second one, oxygen and hydrogen welding, that is called as the oxy-hydrogen welding, and hydrogen is used for the fuel for the combustion. This whatever the fuels are there, those can be burnt directly by taking the atmospheric air, but that will not provide the complete combustion. Not have the complete combustion, to release the more heat for the heating of the metals, that oxygen is used, so that the complete combustion we are going to achieve, and from that the heat we are going to get. And in this gas welding, the two gas cylinders we are going to use. That's one is the oxygen cylinder, and the other one is the acetylene cylinder. And for this the regulators are connected. The regulators means that will be maintain the pressure and allow the proper amount of the gas to flow to the torch, and this is the welding torch. And in this one, both the acetylene and the oxygen gas will flow to this mixing chamber in the torch, where they will get mixed to a proper proportion. And after mixing that one, through the orifice, that is through the orifice that will be coming to the tip of the torch, where that is get ignited by using the lighter similar to that of the domestic stove. Like that it will be get ignited, and when it is get ignited, whatever the flame is there, the flame will be adjusted by using some nozzles are provided here, and that whatever the flame is there, that will be heats the metal up to its melting temperature. And in this one, the temperature reaches about the 3200 degrees Celsius temperature. As we know that in the arc welding it reaches about the 5000 to 6000 degrees Celsius, but here it will be reaching to the 3200 degrees Celsius, somewhat lower temperature, and the slow process of the welding will be taking place. And in this one, the filler material we are going to add. The filler rod we are going to held in front of that flame, so that also melts and along with the base metal, and that fills the gap between the two metal pieces and thereby forms a joint. And whatever these gases are there, those are allowed to flow through this rubber hoses up to the torch, and thereby the flow will be taking place and mixing will be taking place. This is about the gas welding. Then continuation with this one, that how that exactly that will be happening, that is gas welding is taking place. After the initial equipment preparation, the to be welded component setup and safety checks are completed, the pressure regulators fitted to the oxygen and acetylene cylinders are adjusted to draw the oxygen and acetylene gas in the required proportions from the cylinders respectively. Here the initial preparation required for the welding, that is, here the initial preparations means that is the welded component setup, that one that should be the cleaned and properly set for the joining together, and the safety checks, so whatever the flow and leakages are to be checked, and the pressure regulators what are there, those will regulate the flow of the pressure. Okay, that is pressure to that torch, and that is to be adjusted in order to draw, that is in order to supply the required proportion of the oxygen and acetylene to the torch. Okay, that is required. And next one, the pressure regulator in each cylinder is fitted the two pressure gauges. That is actually one is measures that cylinder pressure and another measures that is flow pressure. The respective gases from the cylinder are carried from the pressure regulators to the welding torch using the rubber hose pipe. That is, rubber hose is connected to supply the gas from the cylinder to the torch. Upon reaching the welding torch, these gases are allowed to mix in the mixing chamber and then are let out of the torch through the orifice of the blowpipe. That is, after reaching to the torch, that it is allowed to mix properly and later then come out from the torch through the orifice of the blowpipe. And when it is come out, that one that will be combusted, and there the flame will be formed. The resultant flame at 3200 degrees Celsius is used to melt the workpieces. This temperature is attained. To fill up the gap between the workpiece and add the strength to the joint, filler rod is added to the molten metal floor. Okay, here the gap is there. Now to fill up that one between the two pieces, and so that it will provide a strength to the joint, the filler rod is added to that molten full. The molten metal full that contains the molten metals of the filler rod and the workpieces solidifies to form a welded joint. The molten metal full whatever formed, that is the base metal melted and also the filler rod molten metal. Both are get solidified to form a welded joint. This is about the gas welding, how it will be carried out. The next one here, as we know that one, here whatever the major source for the heating of the base metal up to the melting point, that is the flame, combustion flame of the oxygen and the acetylene. And that whatever the flame is there, that flame how it will be controlled and how much heat it will provide, and all these things we can decide based on the proportions of the oxygen and the acetylene. And the variation in that whatever the gas proportions we are going to have, there are mainly three types of flames. The types of flames. Here there are three types of flames as I mentioned. One is neutral flame, another one is carburizing flame, third one is oxidizing flame. And one by one we will discuss that one. As I told you that one, based on the gas proportions we are going to decide whether it is a neutral flame, carburizing or oxidizing. In the neutral flame, the first point what we have to know that what is the proportion of the gases. And second phase, how the flame will be there. The second point we need to know. Third one, for what purpose that particular flame is used. Okay, that we'll discuss here. In the neutral flame, both the oxygen and acetylene are in equal proportion. Equal proportion, those will be supplied. And here in this neutral flame, it will form say inner whiter cone, then outer flame envelope that will be formed in the neutral flame. And this is particularly used for all types of weldings. All types of gas weldings we are going to use this neutral flame. That is mentioned here. A neutral flame is obtained by supplying equal volume of the oxygen and acetylene. It consists of a small whitish inner cone surrounded by a sharply defined blue flame. Okay, this is surrounded sharply defined blue flame. Most of the gas welding is done using the neutral flame. Most of the gas welding are done using this neutral flame. Okay, next one, carburizing flame. In this carburizing, more fuel is supplied. More fuel will be supplied. Okay, that is acetylene will be supplied in this one. the proportion of the acetylene will be more in the fuel oxygen ratio. And here there are 3 cones are formed, and that we can explain, and this is used for the particular type of the welding, that we can explain here. This is obtained by supplying excess of acetylene in the gas ratio. Excess of acetylene is to be supplied. It has 3 cones, an inner white cone and surrounded by an intermediate whitish cone known as the intermediate flame feather. Okay, this is intermediate flame feather, and bluish envelope flame, and outside bluish envelope flame. Okay, there are 3 cones are there, and this type of flame is used for welding alloy steels, cast iron and aluminum. Okay, for these types of materials welding, we are going to use the carburizing flame. Okay, we can see here that one, the 3 types of cones in this type of the flame. The third one is the oxidizing flame. Name itself indicates that more oxygen will be there in the proportion of the gases, and as more oxygen, it is similar to that of the neutral flame, but the inner cone whatever is there, it is shorter than that of the neutral flame, and it is used for the metal cutting rather than the welding, because it contains the more oxygen, and that will be whenever the metal is forms a molten state, the oxygen will combines with them, that molten metal forms a metal oxide. That is the corrosion that should be avoided, and for that reason this oxidizing flame is used for the metal cutting rather than the welding. That means here whenever the flame will pass over the any metal, that is metal will be get heated, and due to this pressure of that flame, the melted metal will be falls below and metal will be get cut. Okay, that is explained here. This is obtained when there is excess of oxygen gas ratio. It appears to be similar to that of the neutral flame, but the inner white cone flame is shorter than that of the neutral flame. This flame is generally used in the metal cutting rather than the welding, since weld metals get oxidized. And these are the 3 types of flame, and different applications we are going to use the particular flame. Continuation with this one, we are going to discuss about the advantages and disadvantages of this oxy-acetylene welding or gas welding. It's the most versatile process of welding with wide use in various manufacturing processes. It's the most versatile process, that one, and widely used that one in various manufacturing process, various manufacturing applications. This is used that. Low cost of equipment and low cost of the maintenance of the equipment. Here the equipment means here the only 2 cylinders and the torch and connecting hose pipes. That's why the equipment is low cost, and maintenance cost is also lower one. Because of the separate heat source and filler metal, the control can be exercised on the rate at which the filler metal deposits. Here the heat source is separate, that is a flame, and filler material, the rod, the manual we are going to add to that molten fuel, so that can have the control over the how much quantity of the metal is to be deposited. That we can have the control from this type of the welding. The rate of heating and cooling is slow. This helps in retaining the structural homogeneity. Whatever the heating of the base metal is there, as well as that pillar rod, that is slower one. Okay, from the lower temperature to the up to 3200 degrees Celsius go on heats that one. That's why slow heating and cooling whatever is there, that helps to retain structural homogeneity, uniformity in the structure we are going to get from this type of the welding. The equipment is portable, that means that can be carried to any place. It is not required any electrical connection, only we need to carry the cylinders. That's why it is portable, that can be used for the anywhere in the open space also, and it's a multifunctional that one. Okay, that means here the multifunctional means it is not only used for the welding, because apart from the gas welding, it can also be used for the torch brazing. Torch brazing means the flame is used for the braze welding. Okay, this is another type of the metal joining process. free heating and post heating. Okay, the initially the free really some for any to carry out the any other that is operation on the metal, that it is required to free heat it. Then we are going to use heat by using the flame of this oxy-acetylene gases. Then post heating, after that is manufacturing of the any component, if it is required to heat, then we are going to use for the post heating also. The other application we are going to use, that is a metal cutting. The metal cutting also we are going to carry out by using the gas welding. Disadvantages associated with this one are difficult to attain the low cost target while joining the heavy section. That means here the slow heating and slow cooling will be there, as well as the gas cylinders whatever we are going to use, that is costlier compared to that other type of the weldings. That's why here the low cost target we cannot achieve for the heavy section. For the smaller welding and the smaller quantity, we are going to easily at a low cost we can weld by using this gas welding. But the heavy sections it will not, we are going to attain, that is a low cost target we cannot attain. Handling and storage of the gas is not an easy job. Here the compressed oxygen and compressed acetylene gases we have to store in the cylinders, that is handling up those cylinders and storage, that will become difficult because the compressed gas can leak from that cylinders. That is difficult job, that one. It takes a long time for a flame to heat the metal piece than compared to the arc welding. In the arc welding, quickly it will reaches to the 5000 to 6000 degrees Celsius, and it will takes a time for heating in the gas welding. That's why it is a longer time it will takes for the heating of the metals up to the molten state. Therefore the welding is also slower in this one. And possible hazards due to explosion of gases. As we know that acetylene can combine easily with the oxygen or atmospheric air and get combusted, and any leakage from the gases, if it is catches the fire, the whatever the cylinders are there, those may explode, and that's why the explosion hazards will be there. That care should be taken to, that is for the leakage of the any gases. Those are the different disadvantages associated with the oxy-acetylene welding. This is about the gas welding. I am going to continue in the next session. There is a TIG welding and MIG welding. Okay, that you can watch. And thanks for watching, and subscribe, comment and share my videos, and you can watch the next videos also. Thank you once again.